Okay, let's start today paper discussion. Take your paper. Paper number 5. Paper number 5. Okay, I'll start from the beginning. Okay, part A, question number 1. Part A, question number 1. Here given mathematical induction question. Mathematical induction question. This is A level 23 A level paper question. Then given data u1 equal to un plus 1 equal un plus 2n and n positive integer. These are given data set. Then un n square minus n plus 2, need to prove this one. Then induction technique, first you need to prove for n equal 1. When n equal 1, u1 equal 1 square minus 1 plus 2. You do with me, here 2. Therefore true for n equal 1. Now let's assume that the relation is true for n equal p. Here define p. P mean positive integer, p 1 to n value. Therefore, here take this relation up equal p square minus p plus 2. Here again another data. Now when n equal p plus 1, then up plus 1 equal, here up plus 1, this is given data, and need to prove up plus 1 equal p plus 1 square minus p plus 1 plus 2. You need to prove this one. Then let's go to proof. You take this relation 1 by 1, substitute n equal p. Then up plus 1 equal up plus 2p. Here up already given, then p square minus p plus 2 plus 2p. So here p square plus 2p plus 1 take together minus p plus 1. Then for this part, p plus 1 square put minus p plus 1 plus 2. Therefore say true for n equal p plus 1. Therefore, by the principle of mathematical induction, the relation is true. Relation is true for all positive integer. All positive integers of n. That is question number 1. Do with me. Then question number 2. Here modulus inequality question. Now here y1, 1 over 2 x minus 1 modulus, write definition, x greater than 1, x less than 1, x equal 1. Here 1 over 2 x minus 1 minus 1 over 2 x minus 1, here 0. Then y2 equal 4 modulus x minus 1. Then write definition, here modulus 0 value 0. Then x greater than 0, x less than 0, x equals 0. Here are the values. Then for greater than 0 positive, 4x minus 1, for less than 0 negative, 4x minus 1, for equal 0 minus 1. Now you can sketch the graph. I'll do it here. Here x axis, y axis, here half, 1, here first take point 1, intercept half, here minus half, here 1, 1 over 2 minus 1 over 2 graph y1, y1. Then here x0, 0 comma minus 1, 0 comma minus 1 somewhere here. Then v-shaped graph. So intercept here 1/4. So here y2, here y2, gradient 4. Then you find these intercepts. Here first intercept here, equate here 4x minus 1 with this minus half x minus 1. Simplify. Here 8x minus 2 minus x plus 1, 9x equal 3, x equal 3 divided by 9. Then take this minus half x minus 1, here 4x minus 4x minus 1, then minus x plus 1 minus 8x minus 2, then 7x equal minus 3, x equal minus 3 divided by 7. Here minus x plus 1 minus 8x minus 2, 7x minus 3, 7 over 3. Then the inequality given 8 modulus x less than or equal to 2 plus x minus 1 modulus. Need to solve this inequality. Then first divide by 2, 4x 1, 1 over 2 x minus 1 modulus, take 1 the other side. Here 4 modulus x minus 1 less than or equal 1 over 2 x minus 1 modulus. Therefore here y2 graph, here y1 graph, then y1 greater than y2. Then that belongs to this region. Therefore final answer, x element of real set x such that x in between minus 3 over 7 to 3 over 9 with equal. That is question number 2. So definitely in exam there will be modulus mathematical induction question, and also there will be modulus inequality question. Okay, that is question number 2. Then let's move to question number 3. Still we haven't done that yet. Locus part, complex numbers, I'll skip that. Then question number 4, binomial expansion question, again I will skip that one. Question number 3 and 4. Okay, now let's move to question number 5. Question number 5. Here limit question, limit x goes to 0, x goes to 1, 1 plus cos pi x or 1 minus x squared. Here definitely in your exam paper there will be limit question. So here you need to check with the theorem, and also better to put substitution. Let x 1 minus x equal t, 1 minus x equal t, then t equal x equal 1 minus t. Then as x goes to 1, t goes to 0. As x goes to 1, t goes to 0. Substitute here. Then limit t goes to 0, 1 plus cos pi 1 minus t over t squared. Limit t goes to 0, 1 plus cos pi minus pi t over t squared. Then cos 180 minus means minus cos. Limit t goes to 0, 1 plus 1 minus cos pi t divided by t square. Now limit t goes to 0, 1 minus 2 sin square pi t divided by 2 over t square. Here write half angle. Now simplify. Take 2 outside. Limit t goes to 0, sin pi t divided by 2 over t whole thing square. We can take square outside. Okay. Then to apply the theorem, rearrange terms to limit t goes to 0, sin pi t divided by 2 over, here put pi t divided by 2 square. Then to cancel this pi over 2, put pi divided by 2 square outside. Then you can cancel that. Then as t goes to 0, phi t over 2 goes to 0. Then change this limit, phi t over 2 goes to 0. Then 2 over 4 pi square. Here the theorem 1 squared. Then final answer pi square divided by 2. That is question number 5. Question number 5, limit question. Okay, complete up to that. Okay, let's move further. Then question number 6. Question number 6. Here y equal x minus 2 square. Take y1. Then y2 equal 4 minus 2x. Area bounded by the curves. Let's see. Here x-axis, y-axis. Sketch this function. Here parabolic shape, quadratic function. Then vertex 2. It touched 2. Then here parabolic shape graph. y1. Then intercept here 4. Then here 4 minus 2x. Then when x0 y value 4, y0 x value half. y0 x value 2. So anyway, that passes through these 2 points. Here y2 graph. Need to find area bounded by the curves. Then need to integrate 0 to 2. Then area integrate 0 to 2. Then here the function y2 minus y1 dx. Then 0 to 2, y2 mean 4 minus 2x, y1 mean x minus 2 square dx. Now just simplify. 0 to 2, 4 minus 2x minus x square plus 4x minus 4 dx, cancel 4. Then 0 to 2, 2x minus x square dx. Then integrate that. Then area equal 2x square over 2 minus x cube over 3, 0 to 2. Then substitute 2 square minus 2 cube over 3 minus 0. First substitute upper limit, then substitute lower limit and subtract. Then here 4 divided by 3 is square units. That is question number 6. Definitely in your exam paper there will be area volume part. Area and volume part. That is question number 6. Okay, then question number 7. Question number 7, tangent and normal question. Again, your exam paper, you will get tangent and normal question, usually with parametric functions. Now here, x equal t squared. Then dx divided by dt equal 2t, y equal at cube minus t square, then dy over dt 3at square 2t. Then dy over dx by the chain rule, dy over dt times dt divided by dx 3a t square minus 2t, dt over dx reciprocal 2t. Simplify 3at minus 2 over 2. Here derivative. Then it is given that, further given that the tangent drawn to the curve at t equal 1 and t equal minus 1 perpendicular. So when two lines perpendicular, gradient product minus 1. Therefore, dy over dx at t equal 1 into dy over dx at t equals minus 1, result will be minus 1. So the derivative represent gradient of the tangent. So that at instant you put t equals 1 and minus 1, product will be minus 1 when they are perpendicular. Then dy over dx at t equals 1, put 1 here, 3a minus 2 over 2, then put minus 1 here, minus 3a minus 2 over 2 equal minus 1. Then you can simplify this. Here 2, 2, 4, then 3a, here 3a minus 2, here 3a plus 2, here cancel minus minus, multiply, then 4. Then 9a square minus 4 equal 4, 9a square minus 4 minus 4, then a square equal 8 divided by 9, a equal plus or minus 2 root 2 divided by 3. A value plus or minus 2 root 2 divided by 3. Then that means we have two possibilities for that. We have two such cases, plus or minus 2 root 2 divided by 3. Okay, complete up that. That is question number 7. Okay, these papers are parallel to exactly your exam paper. Then practice all. Okay, then question number 8. Question number 8 and 9. Those questions belongs to straight line and circle question. Question number 8. Here two straight lines, L1 and L2. Here L1, 2x, 2y minus x, minus 2, 0. Here L2, y plus 2x minus 6 equals 0. Then you better write here, put all the other side, x minus 2y plus 2, 0 format, ax plus by plus c format. Here 2x plus y minus 6 equals 0. Find equation of the straight line L3 which passes through the intersection point of L1 and L2. And the point minus 4, 4. Minus 4, 4. Therefore, L3 write L1 plus lambda L2 equals 0. Parametric form. Then L1 mean x minus 2y plus 2 plus lambda times 2x minus plus y minus 6 equals 0. That passes through minus 4, 4. Satisfy. Satisfied. Minus 4, 4. Substitute here. Minus 4, 2 times 4 plus 2, lambda 2 times minus 4 plus 4 minus 6, 0. Then here minus 8, minus 12, minus 10, lambda 8, 4, minus 10. Again check 8, 12, 10, then minus 8, minus 4, minus 10. Okay, then lambda value minus 1. minus 1. Therefore, L3 now, x minus 2y plus 2 minus 2x plus y minus 6 equals 0. Simplify. Then here minus x minus 3y plus 8. 0. Then x plus 3y minus 8 equals 0. Here the straight line. Straight line L3. Further show that L3 is the angle bisector of L1 and L2. Then let's write angle bisectors. Angle bisectors. So we have direct formula now. X minus 2y plus 2 or 1 square plus 2 square root plus equal plus or minus. Then take the other line. 2x plus y minus 6 over 2 square plus 1 square root. Then here cancel. X minus 2y plus 2, 2x plus y minus 6. Then plus answer, x minus 2y plus 2, 2x plus y minus 6. Take all one side, x minus 3y minus 8 equals 0. X plus 3y, no? Then minus answer, x minus 2y plus 2 minus 2x minus y plus 6. Then 3x minus y minus 4 equals 0. Here this one angle bisector. Therefore, L3 is this. L3 is this. Then one bisector is L3. One bisector is L3. That is question number 8. Complete? Okay, then question number 9. Question number 9. It is circle question. So we have done that part. Find the equation of the circle which touch the circle x square plus y square equal 4 externally. So here there's a circle given x square plus y square equal 4. Here center 0, 0, radius 2 circle. Sketch it. Here the circle 2, minus 2, 2 and 2. Here the given circle y, x. So the other circle touch it externally and touch y equals 0. Y equals 0 means x-axis. So now the circle is like this. It touch x-axis and touch the circle externally. So here radius 2, radius 2. Take radius r here. Here is radius r. Then the center coordinate, take x coordinate r, say a, y coordinate r, y coordinate r. Here it is. And y equal 2. So y equal 2 mean here it is. Here y equal 2. So here to here, distance 2, no? Then radius will be, r will be 1. R will be 1, no? Therefore now center a comma 1, radius 1. So when they touch externally, center distance equal radius sum. Then center distance equal radius sum. 2 plus r equal, then here this point a comma r, no? A comma 1. A square plus 1 square root. Then 2 plus r mean now 1. A square plus 1 root. Then square both side. 9 equal a square plus 1, a equal 2 root 2 plus or minus. We have two possibilities for this circle. So one is here this side, the other one the other side. So find the equation of the circle, no? Therefore, the corresponding circle write parametric form. Then S x minus a 2 root 2 square y minus r y minus 1 square equal r squared. Here it is. Then here first one, second equation s minus plus 2 root 2 y minus 1 square equal 1 square. Here second equation. Yes, two possibilities for circles. We have two possibilities for circle. That is question number 9. Okay. Then question number 10, trigonometric question. Take left hand side, cot alpha minus tan alpha, take that identity. Then cos alpha over sin alpha, sin alpha over cos alpha. Get common denominator. Sin alpha cos alpha cross multiply. Cos square alpha minus sin squared alpha. Then we say here sin cos 2 alpha. Then here 1 over 2 sin 2 alpha. Then 2 cot 2 alpha equal right hand side. Right hand side. So now that relation you write tan alpha equal cot alpha minus 2 cot 2 alpha. Take this relation. Therefore, by substituting angles here, we need tan 2 alpha, no? Then put tan alpha equal 2 alpha. Then tan 2 alpha according to that pattern, cot 2 alpha, 2 cot 4 alpha. Then put alpha equal 4 alpha. Then tan 4 alpha equal cot 4 alpha, 2 cot 8 alpha. Now all the relations are there. Then 1 plus 2 into 2 plus 3 into 4. Then tan alpha 2 tan 2 alpha, 4 tan 4 alpha. Cot alpha 2 cot 2 alpha, 2 cot 2 alpha, 4 cot 4 alpha, 4 cot 4 alpha, 8 cot 8 alpha. Now you can cancel them easily. Then cot alpha minus 8 cot 8 alpha. Then tan alpha 2 tan 2 alpha, 4 tan 4 alpha, 8 cot 8 alpha equal to cot alpha. Okay, that is trigonometry equation. Not that much hard, but anyway you need to have capacity to deduce these type of relations. Complete that. That is question number 10. So still we haven't done only complex number locus part and binomial expansion, that is. Complete. Let's move to part B question. Let's move to part B question, question number 11, quadratic and polynomial question. So if you have doubt, do with me and check your answers. Then here ax square plus bx plus c equals 0. Here ABC real, and here this must be given here a not equals 0. This must be given. Na? Then find condition to have coincident root for the quadratic equation. We need to find condition. So solve this one. X square plus b divided by ax plus c divided by a0, get complete square. X plus b over 2a, c over a, b over 2a, square 0, x plus b over 2a, square, b square minus 4a square, 4c divided by a, b square minus 4ac divided by 4a square, then x plus b over 2a plus or minus b square minus 4ac root divided by 2a. Then we get x equal minus b plus or minus b square minus 4ac root divided by 2a. Then to get coincident root, for coincident, roots, b square minus 4ac must be 0. Then we have plus or minus here, because of that get distinct root. So then to have coincident root, b square minus 4ac will be 0. That is the proof. Now a over x plus c, b over x minus c equal k divided by 2x. Here given that express a over x plus c, b over x minus c, we need to express as a quadratic equation. So a x minus c, b x plus c, x minus c, x plus c equal k divided by 2x. Then here a plus bx, a c, b c, take c outside, b minus a times 2x, k times x square minus c square, cross multiply, k times x square minus c square, 2x times a plus bx, and here c common, b minus a. Okay. Now kx square subject, before that expand here, 2a plus b x square, 2c b minus a x plus k equal k x square minus kc square. Now take this format, 2a plus b x square, 2c b minus a x, a minus k, 2a plus b minus k x squared plus kc square 0, kc square equals 0. Now here the quadratic equation. Now it says that it has coincident real roots. Now you take the theorem that what we proved. Now here delta 0, delta mean 2c b minus a, b square minus 4a, 2a plus b minus k, 2ac, kc square 0. Now simplify. Here c square, here given c not equal 0, no? C not equal 0, therefore you can cancel c square term. Then here b minus a square, 2a plus b minus k into k, 0. Here the relation now. Now further simplify. B square minus 2ab plus a square minus 2a plus bk plus k square 0. Now we have quadratic equation of k. We have quadratic equation of k. Then k square 2a plus b k, b square minus 2ab plus a square equals 0. Here the relation. Now further given that the possible values of k, k1, k2. Then here quadratic equation of k, you take possible values k1 and k2 now. Therefore root sum k1 plus k2 minus b over a, then root product k1, k2. K2 root product c divided by a, then b square 2ab plus a square divided by 1. Here root sum and product. Now we need to find k1 minus k2 modulus. Cross difference. Here we write k1 plus k2 whole thing square minus 4k1 k2 again whole thing root. Here root sum. Then k1 plus k2 2a plus b square minus 4 k1 k2. Here b square minus 2ab plus a square root. Then here 4 common take outside, that will be 2 now here. Then a square plus 2ab plus b square minus b square plus 2ab minus a square. Cancel, 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 cancel. Then 2 4ab root. Then take 2 outside. Then here 4ab root. Here k1 minus k2. So simple question. So that is question number 11, part A. Now question number 11, part B, state and prove the remainder theorem. When x minus a, when fx is divided by x minus a, the remainder is fa. Here remainder theorem. Remainder theorem statement. Need to prove again. Let Ix and R are the quotient and the remainder. And the remainder when fx is divided by x minus a. You take this relation. Here proof part. Therefore, by the division algorithm, fx of x minus a equal pi x plus r of x minus a. Then fx equal x minus a pi x plus r. When x equal a, we write fa equal a minus a pi a plus r. Therefore, fa equal r. We call remainder theorem. R equal fa. That's how we state and that's how we prove remainder theorem and factor theorem. Complete up to that. Okay, then part B question. Now here, given that pi x cube, px square, qx plus r. Here factor x square plus ax plus b given as a factor. Then when you compare these two, here quadratic, cubic, then there will be linear factor. Linear factor. Then x square plus ax plus b. Then usual linear factor we write px plus q, no? Then but when you compare here leading coefficient 1, then you put p equal 1. Then here constant r, then you put bq equal r, no? bq equal r. Then q value equal r divided by b. Therefore write x cube px square plus qx plus r equal x square plus ax plus b into x plus r divided by b. You better write that way. So one factor given is quadratic one. Therefore write definition. Now expand. Here x cube r divided by b, x square a x square, then x terms ar over b, b x plus r only. Then check it again, x cube r divided by b plus a x square, b plus ar over b, x plus r. Now equate coefficients. By equating coefficients, then x square coefficient here p, here r over b plus a. Then you find r value. So we need to find r, no? Yeah. Then p minus a times b. Then r value p minus a times b. Here one is no. Then x coefficient, x square coefficient, yeah, x coefficient q equal here ar divided by b plus b. Okay, now you need to remove r, cross multiply. Then bq ar mean b p minus a plus b square. You know it is. Then here q minus b a divided by b r mean b p minus a. Then finally q minus b equal a p minus a. Okay, simple question. That is question number 11. Question number 11. Here the specialty not linear factor, it is quadratic. Therefore compare with the original function and guess the other factor, that is linear one. So for linear one, px plus q is the factor, and by comparing leading term, leading coefficient and constant term, you can guess p and q. Guess p and q. That's how we do. Question number 11, part B. Complete. Complete. Okay, then I'll move to question number 14. Question number 14, differentiation. 14 part A, graph. Here function fx given 3 minus 4x over x square plus 1. Now by this one, we need to sketch all now. Therefore, we need turning points, we need inflections, we need asymptote and all now. Therefore, get f dash x first. Denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator 2x. Now get common terms outside. Here minus 2 common, take it outside. Then here 2x square plus 2. Here minus minus. Here 3x minus 4x squared. X square plus 1 squared. Minus 2. Here minus 2x square plus 3x plus 2. X square plus 1 squared. Take again minus outside. Then 2x square minus 3x minus 2 over x square plus 1 square. Then further get factors 2x, x, 2, 1 minus plus x square plus 1. Now we have derivative. So here second derivative not given, then no need to worry about that. Therefore by the function when x equals 0, y value, x0 y value 3. Here y intercept. When y equals 0, x value 3/4. Here x intercept. Then fx equal 3 minus 4x over x square plus 1, get maximum power outside. Then here x 3 over x minus 4, here x square 1 plus 1 over x. Then here we can check terminal limits, 3 over x minus 4, x 1 plus 1 over x. So as x goes to 0, as x goes to infinity, y goes to 0. As x goes to minus infinity, y goes to 0. Here these are tendencies as x goes to infinity, plus or minus infinity. Here no denominator zeros, then no need to worry about vertical asymptote. No vertical asymptote. No denominator zeros. Then here by the derivative, f dash x equals 0, then 2 x minus 2, 2x minus 1, x square plus 1 root square. Then we have two values, x equals half and x equals 2. Here critical values. Then when x equal half, you find y value. Put half here. Then 3, 4, 1 over 2, 1 over 2 square plus 1. Here 2, 1, 4, 5. Here 2, 3 minus 1, 1. Denominator 4 goes to numerator 4, 5. Then here at 2, corresponding value. 3, 4 times 2, 2 square plus 1. 8, 5 of 5. 8, 5, 5 minus 1. Okay. Therefore, half comma 4/5. Here 2 comma minus 1, critical points. Then check f dash x sign. So we have two critical values. One is half, the other one is 2. Then when you consider f dash x, here usual thing, denominator positive, here this part positive, 2 factor product, 2 linear factor product. Two x plus 1 minus half. හතරනේ. Minus half comma 4. Minus half comma 4. Okay. Then here plus minus plus. Plus to minus maximum, minus to plus minimum. Therefore, half 4 local minus half comma 4. Local maximum 2 comma minus 1 local minimum. Now you can sketch. Here xy, then 2 comma minus 1, 1, 2, minus 1. Here that point minimum. Get minimum. Then minus half 4. Minus half 4. Here maximum. Then intercept, y-intercept 3. Here y-intercept 3. X-intercept 3/4. 3/4. Here 3/4. Then as x goes to infinity, y goes to 0. It touched the x-axis. Touch the x-axis. Okay, that is the function. That's the function. Okay, do up that. After we have analysis. Okay, now let's analysis. Then finally it says that sketch y equal modulus fx. Y equal modulus fx. To sketch modulus graph, here this negative region, you mirror it. To sketch modulus function. Then it goes like this. Then let's sketch. Here x-axis, y-axis, then positive part okay. Here for half, minus half, maximum, here this part okay. Up to here it is okay. Here 3/4. Then here for this part, you sketch this side. Then here 2, here -1, no? -1. Here modulus fx graph. Only for negative part, get mirror. Then we need to check 3 minus 4x modulus e to the power x minus x square minus 1 0. Now you subject function, given function first. Then 3 minus 4x modulus e to the power x square plus 1. Now divide 3 minus 4x modulus x square plus 1 equal 1 over ex. 1 over ex means e to the power minus x. Then 3 minus 4x over x square plus 1 modulus. Here this is modulus fx. You need to check with e to the power minus x graph. Then modulus fx function is this, e to the power minus x graph. So e to the power x graph is somewhat like this. Then e to the power minus x means it passes through 1 and definitely it cut these two. Then it can go like this way. Then here we can easily see 3 interceptions. We have 3 interceptions. At least 3 interception. Here there can be another interception. But anyway, definitely there will be 3 interceptions. Then surely 3 interceptions. Therefore, at least 3 real roots. At least 3 real roots will be there. At least 3 real roots will be there. Okay. We can't analyze here this side. We can't easily analyze that one, because rates can be different. Then we can see only 3 intercept easily. Okay. Complete that. Okay, then 14 part B, application of derivative class. In a triangle ABC, AB equal AC. Okay, take this triangle A, here B, C. AB equal AC. Take here X and X. The perimeter 2s. Here take y, y. Then 2x plus 2y equal 2s, perimeter 2s. Then x plus y equal s. then y take s minus x. Here you need to construct a relation. Find maximum volume of the body generated by rotating the triangle about BC. Okay, so here x square minus y square root, here h value. Then when we rotate the sun, so when we rotate the sun like this way, then it creates a cone. Here this part cone, solid cone, here another solid cone. Anyway, then cone volume 1/3 pi h square, here r mean h, no, y, 1/3 pi r square h times 2. We have two bodies, no? Two bodies. Now here the volume, then 2 pi over 3 h squared, then h square mean x square minus y square times y. Now we need to maximize this volume, then need to convert into single variable. Now 2 pi divided by 3 x square y, y cube, then 2 pi divided by 3, here replace, take x, s minus y square, s minus y square into y minus y cube. Now you can differentiate this. Now it is single variable function, need to maximize y, need to maximize v, no? Then differentiate. Now dv divided by dy, 2 pi divided by 3, here s minus y square times 1 plus 2s minus y times minus 1 minus 3y square. Here the derivative, again check, 2 pi over 3 take outside, s minus y square into y derivative 1, and here derivative 2 into s minus y into minus 1, again times y, no? Minus y cube derivative 3y square. Now factorize this, 2 pi divided by 3, okay, expand, s square 2sy y square, here 2sy 2y square, 3y square, then y square, 2y square, 3y square cancel, then 2 pi divided by 3 s square, here 2sy, 4sy, then 2 pi divided by 3, take minus outside with s, then 4y minus s, then dv divided by dy equals 0, to get maximum value equate 0. Therefore 2 pi over 3s, 4y minus s0, then y value equal s divided by 4, s divided by 4, y value s divided by 4. Okay. Now you need to find maximum volume in terms of s, in terms of s. Now check dv divided by dy sin. So here critical value s over 4, less than s over 4, greater than s over 4. Then less than s over 4, here negative with this positive, negative maximum. Therefore v is maximum at y equal s divided by 4, y equal s divided by 4. Okay. Then maximum volume, you substitute that here. Take this relation, 1/3, so you better substitute here, 2 pi divided by 3, 2 pi divided by 3, s minus y mean s divided by 4, square s divided by 4 s divided by 4 cube. Then 2 pi divided by 3. Here 3s divided by 4 square, s divided by 4, s divided by 4 cube. Now 2 pi divided by 3. Here s divided by 4 cube. Take common term outside. Then here 9 minus 1. Here s divided by 4, s divided by 4 cube, take outside. Here 1, here 3 square 9, 8. Then 2 pi over 3 s cube, 4 cube, 8. Now simplify. 4, 16, then pi s cube over 12. Here maximum volume, pi s cube over 12. Maximum volume. Then the specialty of this question, you have to construct the formula that is not given exactly, but anyway you need to put variables, then thereafter you need to get the relation, thereafter differentiate. Okay, complete. That is question number 14. Okay, now let's move to question number 17, trigonometric question. Question number 17, part A. First we need to obtain cos A plus B. Need to obtain, not just write. Huh? We need to prove that one. So here we have geometrical method. Here angle A, angle B. Here do this construction. Here angle B. Then P, Q, R, S, T, U. Here A 90 minus A, 90 minus A. Here 90, then A. Then cos A plus B. Here full angle. They take this triangle. Cos A plus B, PQ divide by PT. PQ divide by PT. Then PQ equal PR minus QR divide by PT. Now PR divide by PT. QR here equal US. US divide by PT. QR equal US. QR equal US. Then PR divide by PR. You divide by PS. Then multiply by PS and divide by PT. Then no change here. No change. You can cancel PS now. Here US. US divide by TS and multiply by TS and divide by PT. Then simplify. PR over PS. PR over PS cos A. PS over PT. PS over PT by this triangle cos B. Minus US over TS. US over TS by small triangle sin A. TS over PT. TS over PT by this triangle, it is sin B. Sin B. We need to prove, not just write. So that is geometrical technique. Hence deduce relation for sin A plus B. Therefore now cos A plus B equal cos A cos B minus sin A sin B. Then need to find sin A plus B, that we need to change cos to sin. Then to change cos to sin, we need aligned angles. Cos 90 minus theta sin theta. Then let A equal pi over 2 minus A and B equal minus B. Then put it here. Cos pi over 2 minus A minus B. Cos pi over 2 minus A cos minus B minus sin pi over 2 minus A sin minus B. Then here pi over 2 minus A plus B. Then cos 90 minus theta means sin. Sin A plus B. Cos 90 minus means sin A. Cos minus theta means again cos. Sin 90 minus means cos. Here minus take outside plus sin B. Then likewise you can deduce. So not to write, just to prove. So you need to deduce by initial relation. That is question number 17 part A. 17 part A. Okay, do up to that. Then question number 17 part B. By using the identity sin square plus cos square 1, need to show sin 2x the given relation. I take right hand side 2 tan x 1 plus tan square sin x over cos x sin squared over cos squared. Now multiply by cos square 2 sin x cos x cos square x plus sin squared x. Now here this part 1 2 sin x cos x times sin 2x equal left hand side. Then similarly the other part take right hand side 1 minus tan squared x 1 plus tan squared x sin squared x divided by cos squared x sin squared x over cos squared x. Then cos square x minus sin squared x multiplied by upstairs downstairs by cos squared. Then cos squared x plus sin squared x. Then here 1 cos 2x. Cos square minus sin square cos 2x equal to left hand side. Okay. Then the other one left hand side 2 1 plus tan x 1 plus I'll take right side right hand side 1 plus cos 2x plus sin 2x. So we know sin 2x cos 2x in terms of tan 1 minus tan squared x 1 plus tan squared x. Here 2 tan x or 1 plus tan squared x. Then subject denominator get common denominator 1 plus tan squared x. Here 1 plus tan squared x 1 minus tan square x plus 2 tan x. Then cancel tan square 2 take outside 1 plus tan x over 1 plus tan squared x. Now that equal to left hand side. That equal to left hand side, simple fraction. Now finally need to express 1 plus tan x or 1 plus tan square x in the form a plus b sin 2x plus alpha. That means you need to simplify this relation 1 plus tan x over 1 plus tan squared x times 2. Here this relation you write cos 2x plus sin 2x plus 1 type. Here it is linear trigonometric equation, linear trigonometric function. Then here coefficient 1 and 1, then 1 square plus 1 square root. Here coefficient 1, 1. Take 1 square plus 1 square root. Take right angle triangle 1, 1. Here this will be root 2. Here pi divided by 4. Then write this way cos 2x 1 over root 2 sin 2x plus 1. Here sin pi over 4 cos 2x cos pi over 4 sin 2x plus 1. Here root 2 sin 2x plus pi over 4 plus 1. Now you compare a mean 1, b mean root 2, alpha mean pi divided by 4. Then 1 plus root 2 sin 2x plus pi divided by 4. You better write the given format. Okay. Then finally need to sketch the function for the range 0 to pi. Do up to this. Do it. Okay. Now we can sketch the graph. Now the function fx root 2 sine 2x plus pi divided by 4 plus 1. Root 2 sine 2x plus pi over 4 plus 1. Then you find maximum value, take here y. Then maximum value, substitute 1 for this. Then root 2 plus 1. Minimum value, substitute minus 1 for this. Minus root 2 plus 1. Then symmetrical axis, get mid value. Root 2 plus 1 minus root 2 plus 1 over 2, we get 1. Period, usually 2 pi, then divide by x coefficient 2, then that is pi. Starting point, take 0 value, 2x plus pi over 4, 0, x equals minus pi over 8. Now shape, sine function positive, then here the shape. Now you can sketch. Let's sketch principal value, principal region first. Then root 2 plus 1 somewhere here. 1 plus root 2. 1 plus root 2. Then 1 somewhere here. Here 1. Then minimum minus root 2 plus 1 negative value somewhere here. 1 minus root 2. Then symmetrical axis, starting angle minus pi over 8. Then here take pi over 8 somewhere here. Minus pi over 8. Then period pi, no? Then here one portion pi over 8. 1, 2, 3, 4, 5, 6, 7, 8. Then 8 portions to complete full rotation. For 4 portions to complete 1. Okay, now here this angle, pi over 8 shifted left side, no? Then here this angle will be pi minus pi over 8. Here period pi. Period pi, no? Here period pi. Then pi over 8 has shifted. Then, so you need to increase little bit to reach pi. Here this angle will be pi now. Here 0. You need to sketch up to here. Then same level. Then that is for 0 to pi region graph. Here solid line 0 to pi region graph. 0 to pi region graph. That is question number 17 part B. Then question number 17 part C, simple part. Tan inverse 2x, tan inverse 3x equal 3 pi over 4. Usually geometrical representation graph, not in your exam paper, but anyway you have to practice that. Inverse trigonometric functions equation there will be in a paper, and general solutions, trigonometric equation, sine rule, cosine rule, those are usually comes with the paper, but graph part not usually there. But anyway you have to practice. Then okay, now here inverse, now take angles alpha and beta. Then alpha plus beta 3 pi divided by 4. Put tan both sides because of this tan inverse. Then tan alpha plus beta, tan 3 pi over 4. Then here this angle we write pi minus pi divided by 4. No? Then minus tan pi divided by 4. Here expansion tan alpha plus tan beta, 1 minus tan alpha tan beta. Then tan alpha mean 2x, tan beta mean 3x. Here 2x into 3x minus 1. Then 5x minus 1 plus 6x square. Then 6x square plus minus 5x minus 1 0. Then find corresponding x values. Here factorize 6x x1 1. Here minus plus 0. Then x value 1 over 6 minus x equal 1. We have two possibilities. Then but if you consider minus sign, that is not satisfied original equation. So here minus no, here right side positive plus. But here if you get minus, left side will be negative. Then this won't possible. But x equal 1, here positive, positive, then sum will be positive, right side positive, then 1 satisfied. Therefore only one solution, x equal 1 is satisfied. Therefore x equal 1 is the solution. X equals 1 is the solution. Okay, complete. So definitely for inverse trigonometric equation, final answer must be check. Okay, then final answer you substitute to the original one. Here original equation. Here from here the equation has changed. Therefore final answer need to check with original one. Take further little time. Now, question number 15. Question number 15. Integration question. Fx x square plus 3x plus 5 x minus 1 x plus 2. Then here partial fractions a b over x minus 1 c over x plus 2. Find partial fractions x square plus 3x plus 5 a into x minus 1 x plus 2 b into x plus 2 c into x minus 1. Now by equating coefficients, first x square coefficient here 1, here a, no? Then let x equal 1, here 1 plus 3 plus 5, 0, 0, here 3b, 5, 8, 9, b3. Then let x equal minus 2, then here 4, minus 6 plus 5, 0, 0, here minus 3c. Here 5, 9, 4, 3, c equal minus 1. Okay, no? 9 plus 3 divided by 3, minus 1. Okay, then 0 to 2 fx dx. Now, instead of this, write 0 to 2, a mean 1, b mean 3, c mean minus 1, like this. Now just integrate. Therefore, now integral equal 0 to 2, just dx, 0 to 2, dx of x minus 1, 0 to 2, dx over x plus 2. Now we have direct integrals, dx integral x 0 to, here ln x minus 1 modulus 0 to 2, here ln x plus 2 modulus 0 to 2. Now substitute limit 2 minus 0, ln 2 minus 1 1 minus ln minus 1 modulus 1, ln 2 plus 2 4 minus ln 0. Substitute upper limit, then substitute lower limit and subtract. ln 1 means 0, ln 1 all are 0, then 2, here ln 2, no? Here ln difference means ln division, 4 divided by 2, ln 2, ln 2, 2 minus ln 2. Okay. Then part B question, part B integration by parts. Take I e to the power 2x sin 3x dx. Here integration by parts we need to take as I, and twice we need to get integration by parts here. Then v function e to the power 2x, dv mean e to the power 2x times 2 dx, du function sin 3x dx, then u minus cos 3x divided by 3. Then uv mean minus e to the power 2x cos 3x divided by 3 minus integral u dv, e to the power 2x 2 cos 3x divided by 3 dx plus c 1. Then further e to the power 2x cos 3x divided by 3 minus minus plus 2/3 e to the power 2x cos 3x dx. Now again get integration by parts. Take v e to the power 2x dv e to the power 2x times 2 dx, du cos 3x dx, then u sin 3x divided by 3, uv minus udv. Then minus e to the power 2x cos 3x divided by 3 minus 2/3 plus 2/3, put bracket here for integration by parts uv e to the power 2x sine 3x divided by 3 minus 2 e to the power 2x 3 sine 3x dx, change arbitrary constant C2. Okay, then further I minus e to the power 2x cos 3x over 3 plus here 2 over 9 e to the power 2x sine 3x, here minus 2 over 3, 2 over 3, 4 over 9, here 4 over 9 e to the power 2x sine 3x, e to the power 2x sine 3x dx plus c. Here take this is I, then I plus 4 over 9 I, here same integral, then get common denominator, e to the power 2x take outside, 2 sine 3x minus cos 3x plus c, then 9i 4i here, then I equal 1 over 13 e to the power 2x 2 sine 3x cos 3x plus c plus c. Okay, that is question number 15 part B, integration by parts question. Okay. Then question number 15 part B. 15 part B. Part C. Here integral I 0 to 1 1 over x plus 1 minus x square root dx. Here substitution given, no? X equals sin theta. Substitution given here. Then dx equal cos theta d theta. As x goes to 0, theta goes to 0. As x goes to 1, theta goes to, here sin theta 1, that means pi over 2. Then same integral I write 0 to pi over 2, dx means cos theta d theta. X means sin theta, 1 minus sin square theta root. Then 0 to pi over 2, cos theta d theta sin theta, 1 minus sin square means cos square, root means cos. Then take here 1. So you can apply theorem here. 0 to a fx dx equals 0 to a minus x dx. Then again integral I 0 to pi divided by 2 cos pi over 2 minus theta sin pi over 2 minus theta cos pi over 2 minus theta d theta. Then 0 to pi over 2 sin theta, here cos theta plus sin theta, 90 minus means sin. So here theorem application, take 2 here. Then add them, 1 plus 2. Usually when we use theorem, we get addition. Then 1 plus 2 same I, no? Then 2i. 0 to pi over 2, here cos theta over sin theta plus cos theta d theta plus 0 to pi over 2 sin theta d theta over sin theta plus cos theta. Here theorem application. Here we have same limit, we have same variable theta and same denominator. Then gather them. Sin theta plus cos theta. Then upstairs cos theta plus sin theta. Then you can simplify this. Then 2i equal 0 to pi divided by 2 d theta. Now I mean 1 over 2 d theta integral theta. 0 to pi divided by 2, then substitute pi divided by 2 minus 1 minus 0, then pi divided by 4. Integral value pi divided by 4. Okay. මේ theorem එක use කරනවා කියලා අපි ගන්න මෙතන මේ මෙන්න මේ pi over 2 0 ඒවා තියෙද්දි අපිට මේ වැඩේ හොඳයි denominator sin cos. Then by applying the theorem, then denominator won't change. Here denominator won't change, limit won't change. Then we can get the theorem. When we use theorem, better to add it. First add 1 and 2, then simplify. Then you can subject easily I. That is question number 15. Do it. Okay, then question number 12. Question number 12. ₹18 are to be distributed among 5 students. Show that there are 35 possible ways to this distribution where each student get at least integer multiple of ₹3. Okay, let's see. A, B, C, D, E. 5 students. මෙතන 35 answer එක නෑ එන්නේ නැහැ වගේනේ. 35 answer එක එන්නේ නැහැ වගේ කමක් නැහැ බලමු හදමු. මෙතන මේකේ combinations ගානත් ගොඩක් වැඩි. එහෙනම් මෙතන මේ at least ₹3 each ගන්න ඕනේ කියන එක පොඩ්ඩක් correct කරගන්න. Get at least ₹3. ₹3 එන්න ඕනේ at least. Okay. Then 3 ඔක්කොම ₹18 නේ. 3 6 3 4 5 3 18 4 3 5 15 3 4 4 4 3 3 3 3 3 6 3 3 4 5 3 3 3 3 4 5 4 4 4 3 3 5 5 3 3 3 5 4 නෑ නේ. I think no any other combination. මෙච්චරනේ combinations තියෙන්නේ. 3 3 3 3 6 3 3 4 5 3 4 4 3 4 3 තව combinations තියෙනවා නම් බලන්න. සෙවන් එකක් දැම්මොත් වැඩේ සෙට් වෙන්නේ නැහැ. at least 3 කියලා මම කිව්වනේ. 5 දෙන්නෙක් දාගත්තත් වැඩේ සෙට් වෙන්නේ නැහැ. 5 5 10 5 5 10 තව 18ක් තියෙනවානේ. නිකන් ලියලා බලමු. 5 5 10 at least 3 කිව්වනේ. 3 3 3 දාන්න. ඒතර කොහේ හරි එකට 2 කෙනෙක් දාන්න වෙනවනේ. ඒ combination එක එන්නේ. හරි. ඔච්චරයිනේ combinations තියෙන්නේ. මෙච්චරයි combinations තියෙන්නේ. හරි මෙතන මේ 35 answer එක නම් set වෙන්නේ නැහැ. අර මේ ₹18 ඔක්කොටම distribute කරනවා. අපි ගමන ඉස්සෙල්ලා මේක හදලා බලමු. Okay. Total ₹18. Then here combination 18C3, 18C3, then 15C3, and again 12C3, and then 9C3, 6C6. So now here we have 1, 2, 3, 4 similar type. Then divide by 4 factorial. Then here 18C3, then 15C3, then 12C4, 8C5, 3C3. So we have 3 equalities. Then divide by 3 factorial. පළවෙනි group එකට ගලපෙන විදිහට select කරන්න. 18C3, then remaining 15, take another 3. 15C3, then remaining part 12. 12, select 4. Likewise you go. Then 18C4, 14C4, then 10C3, 7C3, 7C4, 3C3. So here we have 3 equality and another 2 equality. Divide by 3 factorial, 2 factorial. Then finally add it. Let's check. 18, here 18 factorial, 15 factorial, 3 factorial, 15 factorial, 12 factorial, 3 factorial, 12 factorial, 3 factorial, 9 factorial, 9 factorial, 6 factorial, 3 factorial, 6 factorial, 6 factorial, 0 factorial, 1/4 factorial. First part, simplify. Make කෙනෙක් ඒක ටිකක් ලොකු combinations ගොඩක් වෙනවා ඔතනින් අතර කරන්න. ඒක අර amount එක වැඩි 18 නේ තියෙන්නේ. ඔතෙන් ඉස්සලා ගන්නවා. question එකේ පොඩි doubt එකක් තියෙනවා හරිද? මේකේ මේ ඒ question එකේ වැරද්දක් තියෙනවා. මේකේ answer එක ඇවිල්ලා තියෙනවා මේ equality නැතුව at least 1 රුපිය එකක් දෙනවා කියලා ගත්තාම. එතන equality remove කරලා යනවා at least 1 කියන්නේ combinations 3කට තමයි එන්නේ එතන. හරි. කවන්න මේකෙත් වැරද්දක් නැහැ. මේකේ අර 3කටම එන combination එකනේ මම ගත්තේ. maximum 3 ඒ selection එක ගත්තේ. ඒ කතාවම තමයි එන්නේ question එකේ අවුලක් තියෙන. Okay, completed. Okay, then 12 part B. Let's do this. Series question. 12 part B. You are given 3r plus 1, r plus 1, r plus 2, r plus 3. Then you are equal lambda times fr plus 1. Lambda times, before that just get partial fractions. So definitely we have to get partial fractions. Now this is rational type. Then here a over r plus 1, b over r plus 2, c over r plus 3. Then 3r plus 1 identical to a into r plus 2, r plus 3. I'll write that one directly. ආලා කෙලින්ම ස්ටෙප්ස් අරගෙන ලියන්න මම එක සැරේ ගන්නවා. Substitute -1, -3 plus 1, 1 into 2. Then here 2, 2, -1. Then substitute -2, -6 plus 1, -1, 1. Then 5. Then C, substitute -3, -9 plus 1, -2, -1, -8 or 4, -2 plus -2. Take -1, 1 over r plus 1, here minus 1 over r plus 2, minus 2, 1 over r plus 2, r plus 3. Minus 1 over r plus 1, here plus numerical value वगैरह दे -1, -3 plus 1, -2, 1, 2, minus 1, okay, then minus 2, minus 6 plus 1, minus 1 plus 1, plus 5, then minus 3, minus 9 plus 1, minus 2, minus 1, 8 over 2, 4, 4 ne? Okay. Now it is okay. Then minus 1 over r plus 1 plus 4, 5, now it is there, now it is okay. Now lambda mean minus 1, fr mean 1 over r plus 1, mu mean 4, mu mean 4, okay. Then if you have rational type, better to get partial fraction, then arrange it. Therefore now write ur equal lambda times fr minus fr plus 1 mu times fr plus 1 minus fr plus 2, like this. Then lambda mean minus 1, mu mean 4. Then take this relation. Now we need to get sum up to n. Then r equal 1, put r equal 1, then substitute here u1 equal minus f1 minus f2 for r equal 1, f2 minus f3, r equal to u2 f2 minus f3 for f3 minus f4. You write at least 3 here, r equal 3 u3 f3 minus f4 for f4 minus f5. Then r equal n un fn minus fn plus 1 plus 4 fn plus 1 minus fn plus 2. Then r equal n minus 1 un minus 1 fn minus 1 minus fn plus 4 fn plus 1. Then add all. Then here this way you can cancel all. Then here also you can cancel. Then sigma r equal 1 to n ur equal here minus f1 plus fn plus 1 for f2 for fn plus 2. Here the sum. Then fr, here it is. Therefore f2 1 over 3, f1 1 over 2, then fn plus 1, substitute n plus 1 here, 1 over n plus 2, fn plus 2, substitute n plus 2, n plus 3, okay. Then sigma r equal 1 to n ur, here f1 mean half, no, minus half, then for f2, f2 mean 1/3, fn plus 1 mean 1 over n plus 2, fn plus 2 mean 1 over n plus 3. Now you simplify this. Here common denominator 6. One over 6. 3, 5 over 6. 5 over 6, get common denominator n plus 2, n plus 3, 4, n plus 2 minus n plus 3. Then 5 over 6, 4n, n 3n, 8 minus 3, 5. N plus 2, n plus 3. Further show that the series is convergent. Series is convergent. Then here, as x goes to n goes to infinity, 3n plus 5, n plus 2, n plus 3 goes to 0. Therefore, convergent. Sigma r equal 1 to infinity ur, infinity up to infinity sum. Here limit n goes to infinity, 5 over 6, 3n plus 5, n plus 2, n plus 3. Then here this goes to 0, then value 5 over 6. Then 1 to infinity sum 5 over 6. 1 to infinity sum 5 over 6. Then that is the maximum value. Therefore, sigma r equal 1 to n ur surely less than sigma r equal 1 to infinity ur. And that must be greater than sigma r equal 1 to 1 ur. 1 to 1 ur means first term, then up to infinity sum. Here u1, then sigma r equal 1 to n ur equal 5 over 6 minus 3n plus 5 over n plus 2, n plus 3. Here maximum value 5 over 6. 5 over 6. Then u1 value. Here u1. Here ur given. Then u1 equal 3 into 1 plus 1, 2 into 3 into 4. Substitute r equal 1. 3, 4. 1 over 6. 1 over 6. Then here the value in between 1 over 6 to 5 over 6. 1 over 6 to 5 over 6. Okay. Complete. Okay. Then I'll move to question number 13. 13 part A, matrices question. P minus 5, 3, 6 minus 2. Then P minus lambda I minus 5, 3, 6 minus 2. Lambda 1, 0, 0, 1. Then minus 5 minus lambda 3, 6 minus 2 minus lambda. Here minus 5 minus lambda 3, 6 minus 2 minus lambda. Then here det P minus lambda I given 0. Determinant value. Then determinant mean here minus 5 plus lambda 3, 6, 2 plus lambda 0. Then multiply 5 plus lambda 2 plus lambda minus 18 0. Then 10 7 lambda lambda square minus 18 0. Then lambda square plus 7 lambda minus 8 0. Then factorize lambda lambda 8 1 plus minus. Then lambda equal 1 or lambda equal minus 8. Two possibilities for lambda. Two possibilities for lambda. Then find the matrix X, xy, px equal lambda x. මෙතන නම් මේකේ එක්ස්ප්‍රෙෂන් එකේ පොඩි ප්‍රශ්නයක් තියෙනවා. රිලේෂන් එකේ පොඩි ප්‍රශ්නයක් තියෙනවා px lambda x කියන කතාව එක සෙට් වෙන්නේ නැහැ. මෙතන මොකක් හරි මැට්‍රික්ස් එකක මිස් එකක් තියෙනවා. එතන පොඩ්ඩක් ස්කිප් කරලා දාන්න. px equal lambda x. lambda x කියන එක. මේක ඒ විදිහට සෙට් වෙන්නේ නැහැ. Then complex number part. Part B z x plus iy z bar x minus iy. මේකේ first part එක විතරක් මම කරන්න. මම පොඩ්ඩක් දුරට කරමු. z bar x plus iy x minus iy. Then x square minus I square y square x square plus y square. Then modulus z square. Okay. එතනට කරා. හරි. ඒක එතෙන්ට ඇති ඒක අර මොඩියුලස් රිලේෂන්ස් තා චුට්ටක් කම්ප්ලෙක්ස් නම්බර්ස් වල කරන්න තියෙන හින්දා මම ඒක දැනට ඔතනින් දැන් නතර කරන්න. ඕකේ. මේ පාර්ට් එක ඇතිනේ.